adding and subtracting, so we're still working with radicals or square roots, sometimes rational, that end in a whole number, sometimes not. And here's what I want you to think about. I want you to just treat the radicals as if they are like terms. So this is similar to adding like terms or subtracting. So we've been working on adding and subtracting with like terms all year, so hopefully this is a concept that's not too tricky. We're going to do the same thing we would. So for example, on this one, 4 times the square root of 7 plus 5 times the square root of 7, I see that the radical is exactly the same. That means they are alike. So if, for example, this was instead of a radical, if it was a variable like 4x plus 5x, what would I get from this? Vincent? 9x, right? I'm just counting up how many there are. And what Vincent just did was, because it's adding, right, he added the 2 coefficients, the numbers in front of the variable. It's exactly the same here. 4 plus 5 is how many root 7s we have. So 9 times the square root of 7 is our answer. So the idea is, if the radical is the same, then you can add or subtract them together, and you add or subtract the coefficient, and you keep the radical the same. Just like we did with the variable, the x stays the same, the root 7 stays the same. So that's what this is all about. Now, that one was pretty simple, so let's try to step it up a little bit. 3 times the square root of 6 minus 2 times the square root of 13 plus 5 times the square root of 6. So the way it'll get harder is, first of all, there will be more than just 2 terms, and we'll start to get some that are not alike. So then we just have to look and see, okay, which ones of these could I add together or subtract? Which ones can I combine? Because they're the same. Luke?
5 times the square root of 6 and 3 times the square root of 6.
Good. Keeping the sign that's right in front of each one, so that minus goes with the 2. We're not going to be using it yet. So 3 plus 5 would make 8 square roots of 6 minus 2 times the square root of 13. Now in this case, we're actually done, because what we're going to try to do, and we're going to have to do this on the next one, is to decide if you're done, you have to look and see, is there anything I could factor on these 2 radicals that would help to simplify them and maybe make them the same? In this case, there's no factors we could use. 6 has factors of 2 and 3, 1 and 13. None of that's in common. It won't help me to simplify, and also none of those are perfect square factors. So you can see this one pretty simple. Here, one little notch more complicated with multiple terms. And now, final example, I don't know, I might give one more than this if this is confusing, but this is about as complicated as it should get. 7 root 3 minus 4 root 6 plus 2 root 48 minus 6 times the square root of 54. So not only are there 4, they're all different, and some of them can be factored. Now the 3 and the 6, I can't factor those roots. There's no perfect squares that are factors of 3 or 6 that would help me. So what I'm going to do is I'm just going to leave those alone for now, and I'm going to come and I'm going to work on these last 2. Okay, so don't forget that these are up here, that in our final answer we're going to have to come back and get those. But for now I'm just going to leave them alone. Let's start with the 2. Square root of 48. Perfect square factors. Jim? Change your mind? Okay. Brian? Ooh, good one. All right. A lot of you might have been thinking 4, and that would work. You could start with 4 times 12, but then the 12 would also have to be factored down because it has 4 times 3. So Brian actually found the largest perfect square factor. Again, if you don't, that's okay. You just have to keep going until it's as simplified as possible. But 16 times 3 makes 48, so that would work. If I take the square root of 16, that's 4, times the 2 I had makes 8, and I still have the square root of 3. Let's do the same thing now on this square root of 54. perfect square factor of 54? Jim?
6 and
Okay, good. I think you're going to change your mind again. All right, 9 times 6, I like to put the perfect square first just because we're taking it out, but it shouldn't matter. Square root of 9 is 3, times the 6 that was already here makes 18, and then I still have that square root of 6 underneath. Now, those can't be simplified any further, so I'm going to come up to the front here and just add on those 2 that I left from the beginning. I'm just copying them down here. And now that I've simplified the last 2, now you can see, hopefully, that we do have some that will combine. Right? You can't look at this and just go, oh, none of them combine. I guess that's the answer right there. Nope. We got to simplify them. And most likely, one or maybe all of them, once they simplify, will end up combining with some of the other terms. So I can do 7 root 3 plus 8 root 3. 7 plus 8, 15 times the square root of 3. Now, just be careful with your positives and negatives, just like as if it was a variable. This is a negative 4 and a negative 18. That makes negative or minus 22, and the square root of 6 doesn't change. Is there anything else I can do to simplify? Can I factor these down in any way that would help? No. If you were thinking no, you are right. Some people try to look at this and they go, oh, but this could be a 3 times 2, but you can't really separate them because neither one of those can come out of the radical. They're not perfect squares. So we just leave it like this, and this is our answer. So that's it for today, is just making sure to simplify any that can be simplified and then combining like terms with everything that you've got. That's all. Just that.